What if I told you there are infinite versions of you, existing in parallel universes? This concept of the multiverse has sparked widespread fascination, from movies and TV shows to comic books and video games. The idea of alternate realities has become increasingly evident in pop culture in recent years. However, before we indulge in these captivating narratives, we must recognize that our everyday world adheres to the principles of classical mechanics, trapping us in a tangible and predictable reality. Let me explain. If you know a system state, such as a particle's position and velocity, then you can use Newton's second law to calculate what will happen next. In the realm of quantum mechanics, if you know the quantum state of a particle or wave function, you can use the Schrödinger's equation to calculate what the particle will do next. So this is a rule. If you know the initial state, you can use an equation to evolve that state into the future, right? If you know the initial state of a quantum particle, the Schrödinger's equation only predicts the probability of finding the particle in a particular state at a later time, not the actual position or momentum of the particle. The position and momentum of a particle can only be determined by making a measurement, which causes the wave function to collapse in a particular state. Imagine placing a cat in a box with a radioactive atom and a detector that releases poison when it detects radiation. If the atom decays, the detector detects radiation and releases poison, the cat dies, and vice versa. This is where things get weird. According to quantum mechanics, the state of an atom does not have to be either decayed or not decayed. It is in a superposition state of both at the same time. This superposition state of the atom gets entangled with the detector and cat. Hence, the wave function of everything inside the box is at a superposition state, making the cat both alive and dead. Only once we open the box and make a measurement does the wave function collapse and the cat is either alive or dead. Now this is the Schrödinger's cat experiment. Before I further explain, let me break this experiment down into 3 components: superposition, entanglement, and measurement, to see if any are flawed. First, superposition. Quantum objects can be in 2 different states simultaneously. This is proved through the double slit experiment. If you shoot electrons one at a time at a set of 2 narrow slits cut in a barrier, it creates an interference pattern, each electron going through both slits at the same time. Next, entanglement. If 2 electrons are fired at each other with equal and opposite velocities, we know they will scatter off each other. However, we don't know how, given the trajectories are given by spread out wave functions that only give us probabilities. But once you measure one electron, we immediately know the momentum of the other. It must be equal and opposite, otherwise the conservation of momentum will be violated. However, consider that before the measurement, the momentum of each electron was at a superposition state. Measuring one instantly collapses the wave function of the other, and this would be true even if they were at opposite ends of the universe. This only leaves measurement. When you boil it down, it is just the interaction between one quantum system with another. So, what if we throw out all the rules of measurement? Well, the superposition state of the radioactive atom gets entangled with the detector and cat. So when we open the box, we also get entangled with the systems inside the box. Hence, we see the cat dead and alive. This is because the you that saw the cat alive and the you that saw the cat dead inhabited different universes. At that moment, you are split into 2 identical copies, one entangled with each experiment outcome. You continue to be identical until you open the box. The cat is actually alive or dead. You are just finding out by opening the box. We are just unaware that the other outcome also happened, just to someone who is not you anymore. This interpretation is called many worlds and was formulated by Hugh Everett. If this is true, the branching of the wave function is happening all the time, with infinite versions of you simultaneously coexisting. The next step is turning this theory into a fact.